Choosing a tech career in 2027 feels ridiculously complicated. AI engineer, cybersecurity, data engineering, software engineering, DevOps, platform engineering, even forward deployed engineering. And every role has its own roadmap. Every roadmap has 20 skills, and every person online is absolutely certain that their path is the one that you need to choose before it's too late. So you do what any other sensible person would do. You research, you compare salaries, you watch videos, you open a free account, you maybe start a course or pass even a foundational certification. Or you go a step further. You build through projects, you apply for roles, perhaps even reach some interviews, only to find that your knowledge stops holding together when the questions start to change. Then a new role appears, then the market shifts again, and you reopen the entire decision-making process again. 6 months later, the effort is very real, but it still hasn't compounded into one coherent body of capability and proof that the market can trust you. This is obviously very easy to tolerate when your job isn't terrible. The salary arrives, the people that you work with are pretty decent. On Fridays, you tell yourself that you'll finally just sort your CV over the weekend. And then the weekend arrives, nothing happens, Sunday passes, and it's back Monday. You're on your way to work again, driving into the office. So you call it fine until there's a restructure, a pay freeze, or a wedding, a child, or even your partner is asking you what's actually the plan. And that exposes how long later has actually lasted, right? Because you're not really lazy. Most people watching have made really a big effort. The market just gave you unlimited information and no useful sequence, right, to actually go and implement. But nobody else can actually make the decision for you. And that decision feels difficult because you are asking the wrong question. Which tech career should I choose for the rest of my life? That is not the question to ask. The useful question is, from where I am today, which technical foundation gives me the strongest next move and the most useful options later on? Because you do not have a choice problem. You have a sequencing problem. And once you understand the sequence, choosing a tech career becomes shockingly uncomplicated. If you don't know me, I'm Sulaiman. I spent more than 11 years in tech across software engineering, architecture, operations, DevOps, and AI consulting. And I've helped more than 900 IT professionals, engineers, and serious career switchers build practical skills and pursue new roles. I also have a software company, a consulting company. I've definitely seen and done it all. Now, what I'm going to show you is not another salary ranking video, a personality quiz, or my prediction of which title will be the most fashionable in 10 years. Nobody knows that. Instead, we are going to reduce this whole decision-making process about tech career into 4 simple questions. Those 4 questions are: what does the move need to change? Where are durable problems being created? Which foundation opens the most useful next moves? And can I test the real work before I commit to a career change? By the time that we answer all of these, one practical starting point keeps appearing beneath the careers that you are comparing. But we cannot start with the market, right? We actually have to start with you. So a career decision can only be good or bad relative to the goal that we are pursuing. If your goal is to become a frontier AI researcher because you love mathematics, you are willing to spend years building that depth, and you do not care how narrow the route becomes, right? So that leads to one decision. If your goal is to build consumer applications all day because writing software is the work that you genuinely enjoy, that leads somewhere else. But when I speak to people trying to change or advance their careers, the actual goal is usually much broader than just a title. They want work that uses their brain again. They want skills that keep compounding rather than a role that they have already learned inside out. They want a higher financial ceiling, more control over where and how they work, and the confidence that if their employer does restructure the business tomorrow, they have something valuable to take into the market. They want to feel that in 2 to 3 years, their career will be meaningfully better, not just older. And underneath all of it, they want their life to catch up with what they know they're capable of. Because the frustration is not only one salary, it's feeling bored inside of competence, solving the same familiar problems, attending the same meetings that require your presence, but rarely your judgment. And knowing the role is asking less of you than you can actually give. Now, you can be grateful for the stability and still admit that the role that you're doing is no longer taking you to where you want to go. Gratitude and ambition are not opposites. So the goal isn't find the one perfect job title. The goal is enter a technical trajectory where my capability my truth, and my future options become more valuable as time goes on. Now, that distinction is really important because most career advice compares snapshots. What does it pay today? How many vacancies can I see? Which title is getting the most views? Which certification can I finish the fastest? But a career is not the first salary or the first course. It is where the move is likely to place you after the next move and the move after that as well. Now, the highest paying destination can still be the wrong immediate move if you have none of the prerequisites required to reach it. And a less glamorous starting point can also be the intelligent decision if it builds the capital needed for several better destinations later. Now, the best eventual specializations and the best immediate starting points are not always the same decisions. And this is where your honest starting position really matters, because the same career can be a brilliant next move for one person and the complete wrong sequence for somebody else. If you already work in help desk, infrastructure, systems administration, networking, telecom, software, testing, security, data, or any other technical role, you're not starting from zero. You probably already understand permissions, DNS, operating systems, deployments, tickets, incidents, documentation, or what happens when technology fails inside of an actual business. Those skills might feel ordinary because you use them every single day, but those are career capital. Your strongest move is usually diagonal and not a complete restart. So we want to take the problems that you already recognize and solve them at a greater scope and greater responsibility. If you're moving from healthcare, sales, recruitment, real estate, teaching, logistics, administration, or another career, your starting point is actually very different. You may bring communication, domain knowledge, client management, process thinking, commercial judgment, and the ability to take ownership when the instructions are not perfect. Again, that matters a lot because you can technically be new without being professionally new. Does that make sense? But we also have to be honest, right? Because professional maturity does not replace technical foundations, independent problem solving, and hands-on proof required by whichever field that you go and choose to do. It changes the shape of the bridge, right? It does not remove the bridge. Your previous title does not choose your destination. It changes the length and the shape of the route required to get there. And the same is true of your real life constraints. Your finances, your visa status, your geography, your health, your family, your caregiving, and even time are not excuses to kind of dismiss and ignore. They are design constraints. The decision actually has to follow through and survive. So the best career on a salary chart is useless if the actual transition requires a risk that you cannot responsibly take or a study plan that you cannot sustain. So question 1 gives us our criteria, which is that the move that we make must use or deliberately build on your current capital, improve your financial and professional trajectory, create skills and prove that compound, and fit the constraints of your actual life. Only now can market data help us instead of distracting us. So the second part is, where are the durable problems being actually created? So one of the clearest signals of where large technology companies are building capacity is where they are actually making long-term investments. According to the International Energy Agency, 5 large technology companies spent more than $400 billion in capital expenditure in 2025. The IEA projected that figure to rise another 75% in 2026. Microsoft alone added 88 data centers during its financial year and spent $41 billion in capital expenditure, or CapEx, in its latest quarter. The headline attached to that spending is obviously AI. So the first order career decision becomes, AI is booming, so I should become an AI engineer. But capital does not stop at the word written on the actual announcement, right? The investment wave is expanding data centers and compute capacity alongside demand for advanced chips and power. Then somebody has to turn that capacity into systems that businesses actually use day to day. Those systems need data, right? They need networking, identity controls. They need secure automation, deployment, observability, reliability, right? Cost control. And the moment that they touch like a database, right, a regulated workflow or enterprise network, the implementation actually becomes way more complicated than a general demo that people build. That does not mean that every dollar being spent becomes a vacancy. And it certainly doesn't mean spending turns into jobs at the same rate. Automation, managed services, consultants, vendors, and employees can all observe parts of the work. What the evidence establishes is that large-scale capacity is actually being built right now. And that investment actually creates a chain. More capacity, more systems, more dependencies, more decisions that somebody has to own. So here is the career rule. Capital tells us where demand enters. It does not tell us which job title to chase. For that, we have to move down the dependency stack, right? Imagine a basic technology stack that we got on the screen right here. We've got a business outcome, AI, data, application workloads. We've got delivery, security, automation, observability. We've got compute, networking, identity, storage, and operations. So we want to ask one very simple question here. What has to be true for the layer above this one to work? Let's actually make that a little bit less abstract. Imagine an insurance company introduces an AI system that reads claim documents and prepares a summary for an assessor. In the demo, every looks at the model, right? It reads documents, it generates a summary, and feels like the entire product. Now put that inside of a real business. The documents have to arrive somewhere. They need to be stored and encrypted. Only the correct employees should be able to see them. The application needs compute. Different services need to secure ways to communicate. Changes have to be deployed safely. The system has to be monitored and recovered when something fails. Somebody has to understand and control what it also costs. And because those documents may contain sensitive personal information, the company cannot simply hope that the permissions are actually correct. So somebody has to own these decisions. Now, if you've removed the AI model, the company may temporarily return to manual review. Remove compute, identity, networking, or storage, and the digital workflow will stop operating. That doesn't make AI unimportant, right? And it does not prove the foundational layer creates the most vacancies. Essential work can also be heavily automated. Now, it does show where knowledge can be reused across the greatest number of workloads. Now, look again at the careers you were comparing, right? AI and data roles often focus on more specialized workloads. Security cuts across the stack. DevOps and platform engineering focus on systems that are delivered and operated. Forward deployed engineering adds software, customer, and business delivery, usually after deeper experience. Now, these are not identical roads beginning at the same point. Some of these are specialisms, right? Some are later destinations built from earlier capabilities. If forward deployed engineering is a destination, wanting it does not remove the need for software engineering or systems competence or design, product delivery, and customer communication. So dependencies reveal prerequisites, right? They do not disqualify the actual destination that we're trying to get to. The question that we're asking here is which capability comes first so the later move that we want to do becomes credible, right? Question 2, therefore, gives us a second criteria. Choose a direction attached to a durable production problem, not the most visible product sitting on top of them, which is AI. But just foundational is not enough, right? There could still be a capability that sits very much low in stack and still be a poor investment if the knowledge becomes obsolete before it even pays you anything back. And that takes us to question number 3. Which foundation opens the most useful next moves for us in our career? The half-life of a skill is how long it remains useful before tools or the market reduces its value. Now imagine every vendor renamed its product tomorrow. The interface changes, current AI model was replaced, the certification exams was rewritten. What knowledge would survive in that instance? If all you learned was where to click and how to repeat the glossary definitions, not much would obviously survive. But if you understand compute, Linux, networking, identity, security, troubleshooting, costs, and architecture trade-offs, and a large part of your judgment survives the tool changes, you would still need to learn how another provider implements those ideas. But transferable does not mean identical, but you are translating knowledge rather than starting again from zero. And that is the difference between tool knowledge and having career capital. So the shorter half-life is interfaces, service names, model versions, like I said, certs, whereas the longer half-life is systems, trade-offs, security thinking, troubleshooting, technical communication. It's also why somebody can pass certifications, complete guided projects, and still sound very uncertain in an interview. You memorize an architecture like a server, a load balancer, and a database. Then the interview changes the requirement. The data is sensitive, the traffic is unpredictable, the team is small, the budget is tight, and the application now has to recover if a component fails. Suddenly, the original diagram is no longer enough, because if you learned only the answer, your mind will just go blank. If you understand the underlying problems that you're trying to solve, availability, access, networking, cost, failure, and operational ownership, you can change design and explain why. That's the difference between remembering a tool and developing actual real judgment. And this is also an honest answer around the AI fear. AI can generate syntax, it can draft automation, it can suggest an architecture, it can analyze logs, and it can help you move a lot faster. But the organization still needs the output to be checked against the real requirements. Dangerous permissions and missed failure modes to be caught, cost to be controlled, right? And the production result to be owned. You can outsource more execution to AI, but you cannot outsource your understanding and still expect to take ownership of the actual results. That does not make any role AI proof, right? It changes where the value moves away from recall and syntax and towards judgment, verification, integration, and ownership. AI, data, cybersecurity, and software all contain durable fundamentals on their own. The question is not whether those fields are actually valuable. Of course they are, right? The question is, which first move gives me the broadest useful bundle of durable fundamentals before I actually specialize? And this is where self-studying often goes wrong. You complete another certification, you jump into another topic, and then you change direction before anything becomes independent work or actual credible proof. Connected foundations compound, right? Networking makes security clearer. Linux makes compute clearer. Identity makes architecture safer. Automation makes environment repeatable. Observability makes troubleshooting possible. Another unrelated beginner course resets the vocabulary, right? The projects and the story on your CV. So do not ask only what a career could pay, right? You want to ask, what does it teach? Where can it lead next? And whether you could redirect it without rebuilding from zero. That is the option value. For somebody in IT, the move should extend the systems, permissions, networking, software, or troubleshooting knowledge that we already have, right? For a serious career switcher, it should organize the learning into one coherent base. Research is valuable until it reveals the next meaningful test. After that, more comparison that we do delays the evidence that would resolve the actual decision that we need to make. So you do not need reckless certainty. You need enough option value to commit without predicting the whole future of the market. And because this is a practical starting point rather than theory, it needs one final property. You must be able to practice and prove it outside an employer's production environment. One accessible environment should let you combine compute, networking, storage, identity, security, automation, monitoring, reliability, and costs in a form of a business that actually would use it, and let you build, break, and rebuild the systems repeatedly. Now, put the test together. We need a funded problem. We need reusable foundations, we need durable skills, we need credible next moves, and we need a way to practice real work. Now, one career keeps appearing beneath the others. For the viewer this video is speaking to, the broadest practical starting point at the intersection of all those technologies that we've gone through in those careers is cloud engineering. Now, notice how we got here. Right? We did not begin with AWS. We followed the problems down until the same foundation kept appearing. Cloud engineering, or cloud, is one of the main production environments where compute, networking, identity, storage, security, delivery, observability, reliability, cost, and operations meet. And that final practical requirement matters a lot. Cloud makes the shared systems layer accessible on demand, reproducible, and testable outside an employer's production environment. It does not replace AI, security, data, platforms, or forward deployed engineering. It gives us an environment in which many of the shared foundations can be learned, combined, and proved. Now, the truth is that you are trying to choose the perfect branch, right? But cloud actually gives you the trunk. So cloud is the foundation. If we add security depth, it gives us cloud security. If we add delivery and automation to cloud, it gives us DevOps and platform engineering. If we add data depth to cloud foundation, it gives us data platforms. If we add AI and systems depth, it gives us AI infrastructure. If we add architecture and custom delivery, it gives us solutions architecture. If we add software and custom deployment, possibly it'll give us forward deployed engineering. The plus signs matter a lot here. Cloud alone does not qualify you for every destination, and somebody already deep in a specialist discipline may have a shorter direct route. But if you already work around systems and want to move up, or you have taken serious technical action and need one coherent base, then the reasoning points here, right? And when I say cloud engineering, I do not mean memorizing the AWS service catalog, passing multiple choice exams, or learning where to click inside of a console. AWS is a platform. Cloud engineering is the ability to solve production problems using platforms like it. Right? The actual capability looks a little bit like this. We got the problem, we go into architecture and trade-offs, we choose services from requirements, we have networking, identity, and security, we have infrastructure and automation, observability and troubleshooting, and we have clear technical explanation to the clients. That is why the foundation has option value. You're learning several durable systems capabilities into one production context. The titles will change, right? But the foundation that you build keeps traveling with you. But that is only the market case, right? It is not yet evidence that you can personally enjoy or can perform the work. So we need to have question number 4. Can you test real work before you commit? Most people treat a career change like a one-way door. They imagine resigning, spending thousands, studying for a year, and then discovering that they chose the wrong career. Of course, they freeze, but the alternatives are not bet your entire life on it or do nothing. right? You can turn a frightening decision into a bounded experiment. And that matters because certainty is not the prerequisite for doing actual work, right? Certainty is one of the outputs of doing the work. Watching a career looks nothing like doing the work. You cannot think your way to a personal fit. So for the next 30 days, stop comparing careers and test this one directly. We will use AWS to make the first test concrete. AWS is not the definition of cloud engineering. It's simply the environment in which you will practice the underlying problems. Before you touch the platform, use a separate non-production account, protect the root user of MFA, use synthetic data only, and never connect real company systems or credentials. A budget alert is a warning, not a spending cap. So you want to choose a low-cost resource that you understand, like a virtual machine or EC2. Tag it, verify both tearing it down and billing when the test is finished. So step one, inspect, right? Read 10 real cloud engineering, cloud operations, cloud support, or junior infrastructure job descriptions in the geography where you can generally work from. Ignore the impressive service list for a moment, right? Write down the problems and responsibilities that repeat over and over again. Deploying systems, managing access, automating infrastructure, investigating incidents, controlling cost, building networks, securing data, supporting production teams, or explaining designs. This stops you building a portfolio around whatever happened to appear in a tutorial and then reconnects the learning to actual work. Step two is to build. A small company needs an application where employees can upload documents while working remotely. Only approved users should have access. Every upload should be logged, usage is low, and the budget is very limited. Somebody needs to be alerted if the system becomes unavailable. So do not begin by naming AWS services, right? We want to begin with the requirements. Where does the application run? Where do the documents live? How is access controlled? What is reachable from the internet? What gets monitored? What could fail? How would you rebuild it consistently? What drives the cost? Build a first version inside that sandbox. Make the access intentional. Define the infrastructure in code. Add monitoring, document the decisions, and then one alternative that you rejected. If you're technically new, following guidance for version 1 is actually very reasonable. If you're already in IT, you want to start from the blank brief and make as many major independent decisions as you can. The expected speed is very different, right? The direction is the same, away from following instructions towards making actual decisions. Step 3 is to change and break, right? Now, here we want to change the requirements that we have. The documents contain sensitive customer information. The upload and download path must be now accessible only through the company's private network. The document storage must remain private. Assume that a company already provides managed private access to remote stuff. Do not provision an enterprise VPN for this exercise unless you understand its ongoing charges. Designing and defending that part on paper is very much enough. So what has to change in the design? Then break one part safely. Only then alter the resources that you have inside of your sandbox environment, remove a permission, create a failed deployment, or trigger an alert. Can you identify what happened from the logs or metrics? Can you restore the system? Can you explain why the failure happened or how the design can actually reduce the risk next time? So a tutorial can actually help you recognize the steps in version number 1. But ownership appears when the requirements changes and you can adapt without reopening the original answer. Use AI if you want, right? Because real engineers use tools, but make it explain its assumptions, inspect every permission, test the output, and make sure that you can defend the final decision yourself. If AI did the work and you cannot explain it, the proof belongs to the tool and not to you. Step 4 is to explain and get challenged. Give yourself 90 seconds to explain. What problems were you solving? What constraints mattered? What architecture did you choose? What alternatives did you reject and why? What failed and what did you change? Then put the explanation in front of somebody who actually understands the job. Let them challenge the permissions, the cost, the reliability, the networking, or the trade-offs. Do not defend the first version because your ego is attached to it, right? You want to revise and iterate it. The loop is what passive or tutorial-only self-study often leaves out. Education gives you the inputs, the videos watched, the modules completed, or the certifications collected. Employers actually assess the outputs. Can you build? Can you adapt? Can you troubleshoot? Can you explain? And can you defend the work? One 30-day project does not make you job ready. It gives you something more valuable than another month of abstract comparison, evidence about your fit, and the first real gap in your route. So do not turn this into another framework to memorize, right? Simply notice where the test actually breaks first. If the blank brief completely overwhelms you, the immediate gap is foundations and technical capability. If you can finish only while the tutorial remains open, the gap is independent execution. If you can build a system, but your portfolio contains only screenshots and service names, the gap is proof. The employer cannot see the problems, decisions, and trade-offs, or even the results. If the proof is credible, but the applications produce no response, investigate the roles that you are targeting, the CV, your positioning, how many suitable opportunities that you're reaching, and the market that you're applying to. If you reach interviews, but your reasoning disappears as soon as the requirements changes, the gap is technical explanations and interview practice. So you want to fix the first break. More applications do not repair missing capability. Another certification does not automatically repair unreadable proof. And another career roadmap does not repair a decision that you have not yet put through a real test. Knowing the decision is still not the same as making the decision. A real decision has to remove the decision. If every new video, every certification, every model release, every salary report is allowed to reopen the question, nothing stays in place long enough to compound. So keeping 6 career options feels safe, but temporarily closing 5 paths on paper is what gives one path enough concentrated work to create genuine mobility. So just make a 12-month decision, not a lifetime promise. For the next 12 months, I am building cloud engineering competence. I will build proof in systems fundamentals, production shape implementation, and technical explanation. Unrelated roles and certifications are temporarily going on the back burner. I will review the real evidence after the 90 days. That is the sacrifice that you have to make here. Not quitting your job recklessly, not ignoring your finances, your partner, your health, your visa, your geography, or your family responsibilities. The sacrifice is giving up the emotional comfort of constantly reopening every other option. During those 12 months, the sequence becomes very straightforward. Foundations, build, feedback, revision, proof, market. So learn the foundations, build the systems that force decisions, get feedback before mistakes harden into habits, revise the work, turn it into employer-readable proof, then translate that proof into the right roles, the right applications, and the right interviews. At 90 days, you can review the quality of the evidence that you've built and fix the first break. Do not reopen the entire career decision unless the work itself has shown you the fit is wrong. If your current job provides you financial safety and usable time, keep it as a runway. You do not need to manufacture a crisis before making actual progress, but put dates and outputs against the transition so safe does not quietly become someday. You do not need to wait until you hate your life enough to change it, right? That is a trap with a decent job, right? It never produces enough pain to force a decision. So years can pass while you remain perfectly capable and increasingly stuck. You can decide before you hit rock bottom, right? And this is where the strategy finally starts working because the decision comes before the actual curriculum. One of my students, Mac, was working in Walmart in customer service, moved into IT help desk, and with my help, he's now working as systems engineer at AWS. Silas changed careers at 42, and he came from a non-technical background. He later moved into platform engineering. And we've got plenty of other students as well. You can check out this channel. Those outcomes do not prove the method or guarantees yours, right? They simply show that career movement can begin from a very different starting point. So the bridge has to be designed around the person. So if you've just discovered cloud and not built anything yourself, or not even like tested anything or tried anything yourself, do that for the first 30 days. You do not need to then come and book a call with me and my team, right? If doing the real work shows you that you don't like it, go to another route. Do not force this conclusion because I said to do this, right? But if cloud is already a serious direction for you, you've taken real action, and you can point to where the transition is breaking, then all you have to do is go onto this website and book a call with my team directly. For an IT professional, that might mean months of relevant cloud action, studying, projects, applications, interviews, or delivery using adjacent systems skills at work without being able to turn it into independent capability, credible proof, or even a move. For a career switcher, it means that you've gone beyond curiosity, you've spent real time building foundations, completed work on your own, and put that work in front of a practitioner or a job market. Now, on the call, we're actually going to look at what you've already tried, diagnose whether the gap is technical capability, engineering judgment, independent execution, portfolio proof, or career translation, right? And then we're going to test the route against time, financial, family, visa, and location constraint of your actual life. If the responsible answer is more testing, a different route, or no program at all, then that's the answer that we should reach to, right? The point of the call is to find that out. If it's a fit, We can use the same loop that you've just seen first, right? First, principles, foundations, product shape projects based on our real consulting problems, live coaching and technical feedback that you'll get as well. You'll have the support presenting your work properly to employers. The aim here is not to give you another library of information. It's to actually help you build independently, defend your decisions, and turn that capability into evidence that the market can understand. No program can guarantee that an employer will hire you. What we can assess is whether the method that we have and support will actually fit the gap that your own work has already exposed. Now, choosing a tech career in 2027 is not an act of prediction. It's an act of sequence. We want to define what the move needs to change. We want to follow investments into the durable problems that it creates. We want to choose the foundation with the strongest half-life and option value. We want to test the actual work. We want to then make one time-bounded decision and let the evidence compound. For the viewer, this video is speaking to those questions converge on the same practical starting point: cloud engineering. So don't go and predict which job title wins in 2027, right? Choose a foundation that survives all the job titles. Build the trunk, specialize from the strength later. As always, I'm rooting for you. Go and become undeniable. Like I said, if you want my help, go book a call directly with my team. Links are all in the description below. Peace.